Welcome back to Advent of Code, day 8. This is where Advent of Code is every day in December leading up to Christmas. A new puzzle is revealed, a new programming puzzle, and I blunder my way through it. Eventually, hopefully, so far, being able to solve each puzzle as I struggle with even basic programming concepts that I have once known but forgotten. But let's get stuck into day 8. 7-segment search. Okay, I'm already kind of scared. You barely reach the safety of the cave when the whale smashes into the cave mouth, collapsing it. Sensors indicate another exit to this cave at a much greater depth. Move my microphone a bit. Cave at a much greater depth, so you have no choice but to press on. As your submarine slowly makes its way through the cave system, you notice that the 4-digit 7-segment displays in your submarine are malfunctioning. So, if you don't know what a 7-segment display is, it's a way of displaying numeric values using only 7 light segments. They must have been damaged during the escape. You'll be in a lot of trouble without them, so you'd better figure out what's wrong. Each digit of a 7-segment display is rendered by turning on or off any of the 7 segments named A through G. 4, 5, 6, 7. Yeah. Got it. So to render a 1, all these segments C and F will be turned on. The rest would be off. To render a 7, all these segments A, C and F would be turned on. The problem is that the signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers by producing output on signal wires A through G, but those wires are connected to segments randomly. Worse, the wire segment connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections though. Okay, I need to parse that. The problem is that the signals which control the segments, so turning on each of those 7 segments, have been mixed up on each display. The submarine is still trying to display numbers by producing output on a signal wires A through G, but those wires are connected to the segments randomly. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1, C and F. So it must mean segments C and F are meant to be on. With just that information, you still can't tell which wire goes to which segment. Oh yeah, so B and G are on. So a signal's coming in, say we know we need to display a 1, but a signal's coming in telling this display to turn on segments B and G, but we're getting C and F instead. But we can't infer whether B has been wired up to C or B has been wired up to F. For that, you'll need to collect more information. For each display, you watch the changing signals for a while and make note of all 10 unique signal patterns you see. A pipe delimiter. Wait, sorry, I've skipped. For each display, you watch the changing signals for a while, make note of all 10 unique signal patterns you see, and then write down a single 4-digit output value, which is our puzzle input. Using the signal patterns, you should be able to work out which pattern corresponds to which digit. For example, here's what you might see in a single entry in your notes. This entry is wrapped to 2 lines here, so it fits in your notes. It will all be on a single line. Each entry consists of 10 unique signal patterns. 1, 2, 3, 4, 5, 6, 7, 8. Does that mean there are some repeated? Oh yeah, FBCAD, FBCAD. CD, FBE, CD, FEB. No, they're different. But these two are the same. So, a pipe delimiter, and finally the 4-digit output value. Okay, so this is our 4-digit output value within an entry. The same wire segment connections are used, but you don't know what the connections actually are. The unique signal patterns correspond to the 10 different ways the submarine tries to render a digit using the current wire segment connections. Because 7 is the only digit that uses 3 segments, so a 7 uses these. DAB in the above example, that means that to render a 7, signal lines D, A and B are on. Because 4 is the only digit that uses 4 segments, E, A, F, B, EAFB means that to render a 4, E, A, F and B are on. Using this information, you should be able to work out which combination of signal wires correspond to each of the 10 digits. Then you can decode the 4-digit output value. Unfortunately, in the above example, all of the digits in the output value use 5 segments. See, yeah, and are more difficult to decode. For now, focus on the easy digits. Consider this larger example. Because the digits 1, 4, 7 and 8 each use a unique number of segments. Is that true? 1 uses 2 segments, 4 uses 4 segments, 7 uses 3 segments, 8 uses 7 segments. Okay. You should be able to tell which combinations of signals correspond to those digits. Counting only digits in the output values, the part after the pipe, there are 26 instances of the digits that use a unique number of segments. Hello. Yes, this is a cat tail. Hello. Watch my drink. In the output values, how many times did the digits 1, 4, 7 or 8 appear? Right, this is way more complicated than I thought it would be, considering the previous days. Where do I even start? So I've already pre-created day 8. Okay, Eddie, you can say hello to the camera and then I'm going to put you down. So this is Eddie, say hello. Say hello. Yeah, and then I'm going to put you down. Sorry, Eddie. Let me get my scratch. Whew. Okay, I still haven't quite grokked the puzzle yet. Consider on this larger example. Let me copy you. That looks quite useful. So we got 0, 1. So in this case, 0 is A, B, C, E, F, G. 1 is CF. 2 is A, C, D, E, G. 3 is A, C, D, F, G. 4 is B, C, D, F. 5 is A, B, D, F, G. 6 is A, B, D, EFG. 7 is ACF. 8 is all of them, A, B, C, D, E, F, G. And then 9 is A, B, C, D, F, G. So the reason why it's asking us to just focus on 1, 4 and 7. So this is 1, 4, 7 and 8, so that they all have different lengths. This is length 2, this is length 4, this is length 3, and this is length 7, right? 1, 2, 3, 4, 5, 6, 7. So I really need to think about this, because the digits 1, 4, 7 use a unique number. You should be able to tell which combination of signals. So to render a 1, only segment C and F would be turned on. Yep. I guess also let me just have a look at our puzzle input. Okay, so these are our signals, and this is our output. So do we always get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Do we always get 10 signals corresponding to okay. Still slowly trying to grok this. The submarine is still trying to display numbers by producing an output on signal wires A through G. But those wires okay. Let me time to do some drawing, I think. Right. So we've got our 7 segment display here. Right? And so here is A, B, C, D, E, F, and G. And the problem is let me just tidy this up a little bit. E, F, and G. And the problem we have is, so if I get our wires, usually we would, if this was hooked up as a wire, we would have a wire coming in to A, we'd have a wire coming into B, a wire going to C, a wire going to D, E, F, and My mouse just went all the way then. And finally, G, right? And, you know, these would be A, B, C, D, E, F, and G. But what they're saying is, and let me get all of you collapse you, and then we've actually got 4 of these, 4 digits. I'm going to have to make you a little bit smaller still. So we got our 4 digits. The problem is that these have all been swapped around randomly. These have been shuffled around, so it could end up looking something like this. And for the second display, they're shuffled around, but they could be in a different shuffle order than the first display. Like this, and then we'll just swap B and the C here, and we're going to swap the E and the F here. Is that sort of what I'm thinking here? Signals which control the segments have been mixed up on each display. The submarine is still trying to display numbers, but those wires are connected to segments randomly, yet worse, the wire segment connections are mixed up separately for each 4-digit display. All of the digits within a display use the same connections though. Oh, so I think they're just referring to the fact that all of the digits within a display, so like 1, it doesn't get shuffled for each sort of 1, 2, 5 digit. So usually if you want to display a 1, you need to give, for the first, to display a 1, you usually give it a CF signal, and that will turn on these 2 segments. But as you can see, in my example, it's been shuffled to G and E. So giving this a GE signal, which would usually turn on these 2 segments, actually turns on these 2 segments. But we don't know. So it was saying like, but that's not enough information. Like if you know you're getting a 1 from this. Let me have a look at that. So you might know that all these signal wires B and G turn on, but that doesn't mean segments B and G. And yeah. For each display, you watch the changing signals for a while, making a note of all 10 unique signal patterns you see. Using the signal patterns, and then write down a single 4-digit output value. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the 10 changing signals. Like if we look at DAB, DAB, this usually would give us So if we turned on D, A, and B, would give us this, which we know is not a digit. That's not a valid digit. And the only valid free light digit is a 7, and that's A, C, and F. So by seeing DAB appear in our input, we can infer that D, A, and B have been rewired to A, C, and F, but we don't know what the order is. And then, so let me get all the lengths. So 0 is a length 6 digit. 2 is a length 5 digit. 3 is a length 5 digit. 5 is a length 5 digit. 6 is a length 6 digit, and so is 9. So that's why the example is only using 1, 4, 7, and 8, because they're the only 4 digits that have differing lengths, and we can use that information. So for example 1, let me go back to our example. See here, it's got AB. So usually AB will give us this, which we know is not a valid digit. So we now know A and B must be somehow mapped to C and F in an as yet ambiguous order. So we can do that. We can say AB maps to CF and DAB maps to ACF. And this is where I've been playing a bit of Sudoku recently, and I have a feeling that might come in handy, because this is where we can use a bit of like Sudoku deduction. We have AB here and DAB here. We have an AB pair. So D is the only unique value between the two, and so is A. A is the only unique value between the two. We have a CF pair, CF pair. So now we know that D is in fact connected to A. And but we don't know. What we don't know is whether A and B, the order that A and B is connected to C and F. So in fact, I'm gonna do this. So C is gonna be either, oh sorry, move this out of the way. So C is either going to be A or B. I'm making a mess of this, as is F. So that's the information we know so far. So the next thing to do would be to look at a length 4, a length 4 digit. And as you can see there, the only length 4 digit is EAFB, when it should be BCDF. So we can say EAFB goes to BCD and F. Now we know we've got an E, we've got an A and a B there. So we can eliminate those. We know that's the C and the F. So EF maps to B and D. So B, oh sorry, that should go there. So E and F map to B and D. Again, the order is ambiguous. And let me look at this again. So it was EAFB. Mapped to BCDF. So that was that, and then we need to look at length 7 pair, right? The only other one is length 7, so that would be what's this? 1, 2, 3, 4, 5, 6, 7. So ACED GFB. Let me ACED GFB should map to the only 7 length signal, which I've got here, which is A, B, C, D, E, F, G, basically all of them. I don't see how that's useful, because that's just all the signals. Other than, like, we can get rid of the A, B pair here and the CF pair here. We can get rid of the EF pair here and get rid of the B, D pair here. So now we know C, D and G is mapped. And we know D is mapped to A. So now we just are left with a CG pair here. So we still don't really have enough information to disambiguate these 3 pairs. So CDFEB, CDFE. So these 4 digits, these 4 values here are the output values. CDFEB. Let me make a note of that. CDFEB. If I get my brush, that's C D F E B. That draws a H, which is not a number. So even the output signal is scrambled. 1, 2, 3, 4, 5. Unfortunately, yeah, there's a whole bunch of 5s. Am I even going about this? Am I reading this correctly at all? Unfortunately, in the above example, all the digits. For now, focus on the easy digits. Consider this larger example. Because the digits 1, 4, 7, and 8, you should be able to tell which combination of singles correspond to those digits. So, given this example here, let me make a new given that example there, we know CG, so we know the first digit is a 1. Get rid of that. So we know the first digit must be, oops. Create a new pixel layer. So we know first digit is a 1, the second digit is a 1. We don't know what the 1, 2, 3, 4, 5, 6, so that uses 6s, so we don't know what the third digit is, but we also know that the fourth digit is trying to render a 7. But for the first digit, it's using CG. The second digit is using CG. But it said each of these, like if this is display, I'll do this in purple. This is display 1, this is display 2. This is display 3, and this is display 4. I thought from the text that display 1, is it just a coincidence that both display 1 and display 2 are displaying the same pair of letters? Because whenever there's an example of, say here in this example, there's 2 free character signals, but they use the exact same letters, CGB, CGB, but just in a different order. Does order matter? Order shouldn't matter, because it's just we can encode these signals as a single integer, where each bit, like the first bit corresponds to A, the second bit corresponds to B, the 7th bit corresponds to G, and we just flip those bits on and off to turn the corresponding segments on and off. So the order of the characters within each signal should not matter. So these two are effectively identical. I feel like the hardest part of this to day 8 is just understanding the assignment. So you might know that only signal wires B and G are turned on, but that doesn't mean segments B and G are turned on. The only digit that uses 2 segments is 1, so it must mean segments C and F. For now, focus on the easy digits. Consider this larger example. And then, oh god. I have a feeling I'm not going to be able to get this completed today, as I only have a couple of hours before I need to shoot off. Because the digits 1, 4, 7 and 8 each use a unique number of segments, you should be able to tell which combination of signals correspond to those digits. Counting only digits in the output values, the part after pipe, in the above example, there are 26 instances of digits. What? Like, I mean, obviously we're going to need to understand all this for part 2, but part 1 is so much simpler. I feel like a lot of this information they could have deferred until part 2. They're just asking, like, how many times in the outputs does 1, 4, 7 and 8? And that's dead easy. Okay, I'm really annoyed by that now. So we're gonna do our usual include. Oops, sorry. Damn it! As my keyboard. Why did that happen? Include our input helper, and then we're gonna read our puzzle input, which is gonna be our input day 8. We need to give it our array and count and our I'm just going to call this read day 8 input, which is going to be our function, which I believe, if I just remind myself, bool read day 8 input, takes in a file, gives us our U64, which is our count, and our void pointer, which is our user data. So our U64, our input count, which starts off as 0, as our input count, and our user data, for now, we don't have any. We're not going to have a user data. So I'm going to do f, scan f. Basically, it's the pipe followed by 4 strings. I only care about the output. So this is our out digit 0, out digit 1, out digit 2, and our char star out digit 3. So we're going to give it our out digit 0, out digit 1, out digit 2, and out digit 3. That should have just been an array. Bool did that's int scan count. If scan count is greater than 0, we're going to return true. Else we return false. And then what we're going to do is print f day 8 percentage s percentage s percentage s percentage s. There are string placeholders, and again digit 1. Let's compile. We need to pass in our file handle, obviously. So day 8, we haven't created the input, so let's do that now. Input day 8 dot text, and let us first of all, I'm just going to copy one line, Make sure that is indeed all on one line. Yeah. Compile and run. So our fscanf has not worked. I think we also need to tell it to read but discard the first 10 strings, which is why you use this asterisk. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it does not like that. Yeah, I need to fscanf to remind myself how this works. This is an optional starting asterisk, indicates that the data is to be read from stream but ignored, i.e. it's not stored in the corresponding argument. And then %s string of characters. This will read subsequent characters until a white space is found. White space characters are considered to be blank, new line, and tab. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's possible it's trying to read this pipe character is a special character in fscanf. Doesn't look like it though. Input day8.text. I mean, I could just do %s here as well. Do I need to do that? Let me just put that up there so we can use it. But if I was to do just %s, and let me also get our main. I don't want I only want day8 now. YC, but why? Let's get our input helper. So it's calling handle line. Read day8 input. What am I doing wrong here? F scan F, file pointer, percentages. Oh, is it because I need to pre-populate the length of these? So it's never going to be more than 8, right? So these won't have U. So if I was to do that, yeah, sorry, BE, CB, and then the pipe, and then this. So our format should now work. So we pass in our format, our out digit 1, out digit 2, out digit 3, and then percentage S, percentage S, percentage S, out digit 1, out digit 2, out digit 3. So you can see here it's printing our 4 output values. In which case, because this is a struct, this is going to be our, I'm going to call this a segment signal, and that's basically just going to hold a all letters 8. So then what we're going to do is going to create our struct segment signal, signals equals struct segment signal malloc. Let's just define this as day 8 max signals 1000 day 8 max signals times the size of struct segment signal. This is all getting a bit wonky. And then we're going to pass in our signals. And then our struct segment signal signals. This is going to be our user data. And then what I'm going to do is, for now, don't forget to free it. Let me go back to our here and let's just put in a couple more lines. It's annoying that they put that on a new line, but let me do that. And now if I do F1, day 8 max signals, right, you don't put that. Yeah, so we got each line, CGG, yep. And then that just becomes like our signals count plus dot letters equals our out digit 0. Let me copy paste this 4 times. 1, 2, 3. And now this is going to, it's not the best because we kind of handle incrementing the count within our read puzzle input. So a count's going to be incremented one too many times per line. So I am just going to like do that here and say to do can we handle count better to avoid this hacky bit. Okay, so and then what I'm going to do is delete that and do our print here. So we'll do our bool did read, and if we did read it for signal int, we're not using that anymore, for signal I equals 0, signal I is less than input count, signal I plus plus, so printf day 8 output signals, and then we do printf percentage s and a space, and it's going to be our signals signal I, and we'll print a new line after it. Compile. Assignment to expression with array type. I'm going to say signals count one, two, three, four. And then we don't need to do that. And also, we have to handle the case where our thing is false, in which case we need to do count minus equals 4 to roll back. Again, yeah, it's not the best. But reference memory, memory could not be written. Well, that's bad. That's pretty bad. Day 8 max signal size of struct. Or rather, we could do count plus 0. You could do it that way. But it still doesn't like that. Why not? Why don't it like? Let me comment this out. So like our signals 0 dot letters, say that equals, right, char just make sure this works. Foo equals test printf %s foo, or rather signal 0 dot letters. I want to see if assignment makes integer from pointer without a cast. Ooh, yeah, that causes issues. Assignment to expression with array type. How do I what sort of size of our signal letters is 8. C assigned to char array. Might have to use stir copy here. Like this, and then basically we need to do stir copy signals count plus 0 dot letters out digit 0 8. One, two, three. 1, 2, 3. Something like that. And again, what's stir copy char source? Oh, we don't give it a destin. We don't give it that because I guess it uses the null terminator. I guess we never reduce the end copy, then it is that. Still doesn't like it. Why not? Maximum number of characters to be copied from source. I guess it has to be 7, right? I only want to copy 7 characters. Let me, I mean, we do calloc. And then printf percentage s new line, and I want out digit 0. So I want to see that. So that's this one, and then this one, and then this one. And then if I don't do that, so signals count, I only want to copy the first 7 characters, but it doesn't like that. Why? Let me copy this. Output signals, so it's doing null, 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 but can I just do like interesting, that doesn't like that. Well, if I just did 0, still doesn't like it. What's wrong? This obviously isn't working. Destination source. So the actual copying bit, I just want a C structure with fixed chart array. Arrays in C are not assignable. You need to use stir copy. I mean, that's what I'm doing. But for whatever reason, I'm doing stir copy. And if I should really be including string.h. That works. And if I did malloc instead, I don't know why that Sorry, lots of reading and Googling. No. String. So like yeah, if I create a struct segment signal, so signal test, that should then create this on the stack with this array letters 8, and then I should be able to say stir copy signal test dot letters bar, and then if I printf %s new line signal test letters, we get that. So the problem was, if say I made 5 of these and I said like the second one, I'm going to do the second one, that works. If I was to present the size of our struct segment signal, it returns 8, which is correct. And our size of our signals well, whatever this is, or rather, sorry, this 8,000. So if I was to do signals to the letters, signals to the letters. That I don't think you do need a pointer, right? No. So it's just when I'm like allocating this on the heap, it doesn't like it for some reason. Which is really weird. What happens if I was to do this? Because that should point to the exact same address. Like, you can absolutely cast this to a address off. Memory could not be written. That's really weird to me. C write to char array on heap. And we should get the same. Do we get the same issue we use calloc? Yeah. Don't get it. Do not. The alternative is to make this a char, but then I need to I just want a list of strings, right? So it's an array of output signals, but we actually want right. Let me get rid of you. And then for we'll just say output signals I is equal to uh, 8 times size of char. So our output, our signals then just become our char star output signals, because it's an array of character arrays. So far so good. And then we basically need to do stir copy output signals count plus 0 out digit 0, and then I'm going to delete all u, printf %s uline output signals count, just to see if that works. It does. So I'm gonna do that 4 times. So that 1, 2, 3, 1, 2, 3 plus equals 3, and then if we do that, we now get all our output signals: 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So there we go. Another time I will try and figure out why having a structure with a, because this to me seems functionally exactly the same what's going on in memory and the processor. And there must be some part of the C language I'm misunderstanding. So now we basically need to go through each of these and count the length. So basically just becomes still n. So we'll just do char star signal equals output signals signal I. There we go. Len 7. Oh, let me do a space. Len 7, Len 5, Len 6, Len 4, Len 6, Len 3, Len 7, Len 2, Len 2, Len 2, Len 6, Len 3. So our unique signals were, our unique sort of lengths was 1, 4, 7, and 8, right? 1, 4, 7, and 8. Or rather, the unique length for that was 2, 4, 3, and 7. So we can say equals still n signal let's do our u easy signal count. If length is equal to 2, or length is equal to 4, or length is equal to 3, let me flip these around, or length is equal to 7, and we'll say our easy signal count is incremented, and then we'll do a printf day 8 count of easy output signals is %u. Count of easy output signals is 8. So let's, I mean, we can try and copy this, go to our inputs, paste it, and run it again. Count of easy output signals is 26. So let's get our real puzzle input. Boom, run it, and our count of easy output signals is 352. That's the right answer. Okay, I'm going to pause this video here because we've completed part 1 in an hour and 20 minutes. So I'm going to cut the video here and upload another video for part 2. I'm not even going to look at what it's going to be yet. But yeah, if you made it this far, well done. Bye.